Okay guys, so we are back and we were on writing down the equation of G in the form of this now. Okay, so if we check the equation G, we need, if we want to do the equation of a straight line, we will need a gradient and at least 1 point. All right, and yeah, we need the gradient and at least 1 point. And then remember the coordinate of B here is 3:0. So we need two coordinates that are on the line, of which the only two coordinates we have is this coordinate and that coordinate. So we're going to use the two coordinates to find the gradient. This is in analytical geometry, you learn how to calculate gradient. So the first coordinate is 0:3 and 3:0. So I'm just going to do that. That is 1.4. That is 1.4 on the next page now. So 1.4, we have C, which is 0:3. We have B, which is 3:0. So we're going to find M. Maybe let's call this our X1 and Y1, our X2 and Y2 according to analytical geometry. So gradient is Y2 minus Y1 over X2 minus X1. The Y must always be on top and the X must be at the bottom. You can say Y1 minus Y2, but here it's also going to start with X1 minus X2. I only stick to this because I do not want to confuse myself. Now my Y2 is already named, is this 0 in the bracket because I'm substituting. My Y1 is 3. My X2 is 3. My X1 is 0. So 0 minus 3, 3 minus 0. So this is 0 minus 3. And then this is 3 minus 0. I'm having -1 as a gradient, right? So this gives me -1. So that's my gradient. My gradient is -1. And I'm going to take at least 1 point. I can take this point or that point up to me entirely. Therefore, you can say Y minus Y1 equals to M X minus X1. I prefer this formula. Some they use Y equals to MX plus C. Nothing wrong with that. I prefer this one. So I will only substitute on Y1, X1, and on M, right? On M and Y1 and X1. So I'll take any point. I can take the 2's, I can take the 1's, as long as on X I put X and on Y I put Y. So this Y I'm going to leave it because I'm not substituting on it. Minus Y1, maybe let's use this one, is 0 equals to my M, I just found it, is -1. On X I leave it, minus X1, because I use this point of 0, X1 is 3. So X1 is 3. Y minus 0 is Y. This times this is -X. This times that is +3. So I found the equation of M of G of X. So on Y we can put G of X is minus X plus 3. So that is the equation of G of X. It's the equation of a straight line. Okay. Write down the equation of H going through point C and parallel to the x-axis. Write down the equation of H. The equation of H. So this is the equation of H. They say it is going through point C, and that line is parallel to the x-axis. So if we are trying to maybe visualize how that line looks like, it's something looking like this. It's something looking like this. It's this line, and then this line, it is going to be parallel. This line is going to be parallel to the x-axis. If it is parallel to the x-axis, the gradient of a horizontal line, you must know it is always 0. The gradient of a horizontal line, it is this line. Gradient of a vertical line, is not defined. A vertical line does not have a gradient, okay? Because the gradient is a slope. It is how steep the surface is. So if you are walking, for instance, on a ground, you don't feel the heat. But once maybe you are climbing a bridge, maybe your line looks like this, then this we call a gradient, is a slope. So if you are climbing a slope that is like this, and this is your ground, you're gonna feel more pressure than when you are climbing here. So the more it goes up, the more the gradient goes up. But if you are climbing, if you are walking here on the ground, and then you can't climb this walking, you can't climb a straight wall when you are walking, so it does not have a gradient. I think that is the best way that I've explained it. So we have the gradient is already 0, and we have point C, which is 0 and 3. So we can go back and use that equation. So that is 1.5. That is 1.5. So that is 1.5. Y minus y1 m x minus x1. So we have the gradient is 0. We have point C, which is 0:3. So we substitute it. Remember I said we substitute here, here, and here. So on the y, we have the 3 minus y equals to the 0, x minus, on the x is 0, x1 is 0, and then 0 multiplied by this is 0, 0 multiplied by 0 is 0, y minus 3, 0 minus 0 is 0, so the answer will be y equals to 3. That's how the answer will look like. It's going to be y equals to 3. So we've answered 1.5. 1.6, write down the average gradient between point A and point C. Point A and point C. If we are to do the gradient between point A and point C, it is on a horizontal surface. Point A and point C are on a horizontal surface. If a person is walking from point A and point B, oh, not point A and point B, it's point C, isn't it? Oh, yes. I was about to say this one, the gradient is 0. So, but here, they are not looking for this one. This is the gradient they are looking for. They are looking how steep. They are looking for how steep is this from point A to point C. So point A, we have the coordinates is -1 and 0. So now we are answering 1.6. 1.6, point A is -1 and 0. Point C is 0:3. 3. That's, I got it right there. -1 and 0, and then 0 is to 3. Okay, so now I do the gradient. Do you see how much analytical geometry is connected to functions? So really, if you don't know how to do your analytical very well, you are in trouble. You must go and really look into it. Okay, so let's quickly do gradient. So that's gradient is y equals to y2 minus y1, x2 minus x1. That is further, the y2 is 3, the y1 is 0, x2 is 0, and then x1 is minus 1. So the final answer to that, 3 minus 0, 0 minus of minus 1. So that is 3 minus 0, and that is 0 minus of minus 1. So that is positive 3. So we put positive 3. So that is the average gradient between point A and point C. That's the gradient between point A and point C. Now, they're saying write down the values of x for which f of x is above 0. Greater than 0 means above 0. Okay? So, I tell people, if you have a Cartesian plane, the upper side, the values of x that makes of the upper side of the function, it is the positive side of the function. The lower side of the function, it is the negative side of the function. And for a graph to move from the lower side, from the lower side to the upper side, it switches in between the intercepts. So if a graph is like this, we know that from this point to this point, in between this point, the graph, part of the function that we're looking for, it's in the upper side here. It's in the upper side. So let me erase all of these. Okay, before I confuse you. So we already know the coordinate here is -1, and that one is 3. All right, so this, I'm going to highlight, this is the part of the function that is positive. This one here, it is part of the function that is positive. And this part of the function, it will be in between -1. I'll just highlight there, right? So between -1 and 3, the function is positive. And then after 3, if you are going to 4, the function is negative. The function is negative here. The function is negative here, because it's within the region where the negative region. Remember, below the x-axis, the region is negative. So anything that is maybe x equals to -2, its image will be somewhere here, is negative. So anything less than 1, anything greater than 0, the function is positive. But anything in between -1 and 3, the function is positive. So here they want where it's positive. So where it's positive is going to be when x, it is the element, right? They don't, because at this same point, the function is 0, is equals to 0, and on that point the function is equals to 0. So here they don't say greater or equal to 0, so we don't include those points. So that is -1, -1, and 3. All right, and then here the first one, it is x must be less than -1. That is the first one here. X must be less than -1, and x must be what? Greater than 3. It must be greater than 3. X must be greater than 3, because here we want where it's negative. So where it's negative, as I explained and everything. So basically we are done with this question. 20 marks to ourselves.